This is a project presentation for the Internet of Things Software Development module. This project is covered Culprit and it's by Richard Seaman. So to give a very quick overview of the project, so I'm not going to go into it in detail because it's in the report, but we have first and foremost a temptation cupboard in the bottom right over here, which houses all the drink and chocolate and good stuff, and lurking in the back is this Raspberry Pi sensor setup. So the purpose of this project is that whenever anybody opens up the cupboard, their image is captured so that they can be named and shamed. All of this is within range of the home Wi-Fi network, so I'm free to SSH into the Raspberry Pi when it's up and running from my laptop. The Pi then communicates with the cloud. It downloads configuration settings and uploads images and readings, the readings being temperature and humidity from within the cupboard. The cloud, or specifically Firebase and Google Storage, then stores this information, and on the front end there's an iOS application which does the opposite. It uploads the configuration and downloads the images and readings for the user to see. So it's a very quick overview. Here's an up-close image of the hardware, so the Raspberry Pi, camera, ultrasonic sensor, screen, LEDs, temperature, humidity, buzzer and button. So there's details of that in the report, so I won't focus on it. And here's just the cupboard itself. In the videos, it's actually empty just because I was taking videos of it, needed it to be empty, but here it is actually working away. So the next thing you'll see is a run through of this program in action. Okay, so I have three things going on here. First one on the left over here is Firebase real-time database. It's just the console that I'm logged into here. In the middle I've got a simulated iPhone 6s that I'm going to run my iOS application on. And on the right hand side here I have just a terminal window, and I'm actually going to SSH into the Raspberry Pi right now. And the Raspberry Pi, it's actually running the Python program, and it's installed in the cupboard at the moment. So if we just do a PID of the program, you'll see that that's the process ID over there. It is actually running. And if I change directory into where it is and just list out the files, you'll see that I have an archive folder, images folder. So the images folder is where any images that are taken are going to be saved. Once the images are processed, they're going to be put in the archive folder. I also have a log file here. They're also archived once the program shuts down. The main is the program itself. The README is a very quick README. It was created with Git, and this JSON is for authentication for Firebase. But if I just tail the log file here and follow it, so here we'll see what the program's actually doing. So I'll leave that open there, leave it running, and I'll come back to Firebase here and explain that. So their real-time databases in Firebase use a JSON tree structure. So overall, Culprit, I've got three root nodes. The first one is conditions. So if I expand that out, you'll see I've got quite a few entries here. The program's been running it for a while, and the key values that I've used is actually epoch time. So it's time in seconds or milliseconds maybe since a particular date and time. So what it does is it ensures uniqueness for each time series data that I'm trying to upload. These are always going to be different. So if I expand that out, for each one I've got a humidity reading, temperature reading, and a human readable timestamp. So this is from a few days ago there. And again, plenty of them, each one the same. So that is conditions. The next root node that I have is config. So if I expand that out, you'll see 6 different values here. Now what these are you can see there, like time between checks, background. They're settings that are used within the Python program on the Pi, and what the Pi does is it queries this database, sees if any of those values are different. If they are, it syncs them up and uses them instead. So if we come back over here to the terminal, yeah, you can see this checking for config changes. So it's doing that every minute or so. I've actually sped up some of these checks just for the purposes of demonstration. Usually they'd be a bit slower, but I've sped them up just so we can see. So they're downloaded or checked by the Pi to see if they're different, and they're adjusted using the iOS app. So I'll show you that now in a second. The last node is Culprits. So again, this is time series data, so I've used the key as the epoch time to ensure uniqueness, and for each one, if I expand one out, you'll see the image name and the timestamp. So what this branch or tree is used for is every time somebody opens the door, an image is taken of them, so that image name is stored and the timestamp that it was taken. Just to note that the image name is exactly that, it's just the name of the file. The file itself is actually uploaded to a bucket on Google Storage, so that bucket has a particular URL which the app is aware of, so once it knows the image name here, it can just append that to URL and go ahead and download whatever image it wants. So that is the Culprits node. So that's Firebase. If I come over to the app here, Cupboard Culprit is the name of the app I've developed. There's the icon here, so I'll launch that up. And here we have Exhibit A is myself raiding the cupboard. So this app is a tab-based application. It's got culprits and settings at the bottom that you can choose. So the culprits tab allows you to cycle through each of these culprit values, look at the associated image and the timestamp value here. So if I go cycle back through a few, you can see me messing around here, setting it up, taking pictures of it. There's my girlfriend genuinely looking for a treat on the high shelf. Somebody got the door closed in time on that one, and so forth. I can go back. Now that loading screen there is that this particular image hasn't been viewed on the app yet, so every time it downloads a image, it's going to save it locally, so the next time I look at it, it's not going to see this loading image, please wait. I can also tap on the timestamp up here and select what I call the raid time, so a raid being somebody opening the cupboard and looking for some chocolate or whatever. So I head back in time. Again, there's my sister was over for the weekend, she was looking for something, there she was, and me again. So you can see there's my girlfriend missing. So I go back to the latest one there, and then the other tab is settings. So as I mentioned, these config values in the real-time database, this is where I'm going to set them, and they're all on sliders so that there's a bit of validation there. I can't set them to something ridiculous. There's a minimum and maximum for each. So each of the 6 values are here, and then a sync button at the bottom. So if I slow down the sensor settings up at the top here, just to explain that, actually the sensor readings are taken every 5 minutes in this instance, but they're not uploaded to the database every 5 minutes. So those 5-minute readings are averaged over 60 minutes in this case, and then the average reading is uploaded to Firebase. So if I slow that right down to every 30 seconds let's take a reading, and every 5 minutes let's upload the average. If I sync this now, let's keep an eye over here, syncing. So yeah, look, they've gone orange, they've changed to 30 and 300 respectively, which is 30 seconds and 300 seconds, which is 30 seconds and 5 minutes worth of seconds. Over on the right hand side here, let's keep an eye now. This is the Pi, the program running on it, so every so often it's checking for config changes. So it should, next time that runs, yeah, config update, so it's updated itself, and it's also uploaded a average temperature and humidity reading. So you might have seen this conditions over here go orange, indicating a new entry in there. So that has been done. What else has it been getting up to here? So we go back up to the top. checking for images to upload. So what it's doing is every so often, if there's an image found in the images folder, it's going to process that. So it's going to resize it, which literally reduced the file size by like 98% or something ridiculous. Then it's going to upload it to the bucket online, and it's going to move the original image to the archive folder. So that's what it's doing along here, checking for images to upload, images found 0 in all these cases. This deleted old file actually is, when it's processing images, it's looking to see if there's any in the archive that are older than a week, and if there are, it's going to delete them. That's just to make sure that, you know, I don't put far too many image files in the archive folder and never clean it up. So it's actually found a couple of them from 280430. Yeah, and we're on 7th of May, so yeah, that's actually a week ago when I was testing this out. It must have been, so I was deleting those originals. Checking for config changes again. Delete null file. Okay, so what I'll actually do now is I'll run out to the kitchen where the cupboard is. I'll open up the cupboard. I'll let it take a picture of myself, and I'll record a video as I do it actually, and leave this video running to see all the config changes. So okay, here goes. So I'm just back from opening up the cupboard there. I've taken a video of it, so I'll be able to include that too. Looking at our log, let's see what it's done. So where were we? I think we were, yeah, it must have been about here. So I opened the door, it detected that it was open, it took a picture, it saved that image as that. It's uploading to Firebase over here in Culprits. So if I go down to the very last one there, image name 2018-0507, 2018-0507, 1956, 30, yeah, that's the one. The image name and the timestamp, and this ignoring door open too soon after previous. What that actually means is it's only going to take a picture once the door has been closed and is opened again. It's not going to continuously take pictures if the door is kept open. So I had the door open for quite a while. Checking for images to upload, so in this case it's found one that was just taken. It's processing that image. So again, processing, it's resizing, uploading, archiving, and then it's just happened to find an old file that is deleted, and then it's continuing on in that fashion. So I shall stop the recording there after showing all that. Actually, no, wait, sorry, Culprits. This was the latest one a second ago, but now it has been uploaded. Come on, yeah, so there's me logging in, and I'm taking a video there, so you'll see it from the other side of that camera in a second, right?